next talk by Sandler, Finding Serenity in Deploys.
Thanks. Hello everyone. I'm going to tell you a bit of a story. I'll start off a little bit about myself. So these are the handles you can find me by online. Please feel free to message me, even if it's in all caps, that's all good. I've worked for Zendesk for a couple of years, which is relevant because the story I'm telling is about Zendesk's evolving deploy process. I will warn you, first of all, that this is my first job since university, so I can't really contrast our experience with other companies. Before I go on, I'd like to say a really big thank you to the organisers and to everyone I've met, because you've all been amazing and intelligent, really friendly people. And I'd especially like to thank them for allowing me to use a microphone despite last night's karaoke. So I'll start off with a short definition. If the person next to you seems to know all about this, please wake them up in 30 seconds or so. So basically, a deploy is made of 3 simple steps. We've got to package up an executable with our library dependencies and our assets and our code, obviously. We've got to copy our web app to our servers, and then we've got to reload the service. Even in the most Byzantine deploys, I think that almost every essential step can be fitted into one of these 3 categories. I mean, you've also got database migrations outside of that, but strictly speaking, I don't consider them to be part of a deploy. So how do we do this? We've obviously got lots and lots of options. Some of the tools on this slide are some of the most well-known and popular ones, but we've got loads of really reliable and battle-tested options to deploying our code. So where's Docker? This talk is not really about the nature of how you structured your architecture or your particular apps, but a mention of Docker is guaranteed. I think it's an unspoken code of conduct at conferences, so it's coming. So anyway, I know what you're probably thinking. Deploying must be pretty easy. So I guess put your hands up if you've never ever had any problems with deploying. Oh, no way. Yeah, sometimes deploying can be pretty hard. This is a Twitter account that I like with a couple of potential scenarios where deploying can go wrong. So bad performance is obviously a problem. And also, this particular story, I think, is a side effect of bad communication within the organization. So nobody wants this to happen. So maybe deploying is not so simple after all. And there are some particular circumstances that can make it even harder that we experienced. So onto my story. The Zendesk story starts in around 2007. And the homepage was pretty simple back then, whereas now we've got a web team and marketing team. They give this page a lot more attention. This is from the Internet Archive from back in 2007. So we started pretty small. A lot of really important information, including passwords and credentials, was just stored in one person's head, who was the engineer. And as you can see, we had just one office, one Rails app, and obviously one data center. So this was engineered, and deploying to engineered was not a problem at all. We were already using Capistrano back in those days, which is a configurable open source Ruby tool for those that haven't used it. We were using it for essentially copying up the current branch that you had checked out on your local machine up to the servers, pre-compiling assets, doing whatever else had to be started, bundling, and restarting the app. Actually, I went digging through our source code, and the oldest commit I could find was from about 2008, and that was an import from SVN, or like a repository organization. So just to give a bit of a picture of where this all started, we're talking about SVN, Rails 2, and Mongrel, if anyone's familiar with that web server. We've also been using New Relic since the really early days to help us, among other things, troubleshoot deploy problems. So Zendesk grew pretty fast, and it even became difficult for the operational support side of it to keep up with the changing face of the product. And what I mean by that is we'd suffer from lead times trying to get more hardware just because our traffic was growing so fast and we needed to support more and more customers. So we did expand. You can see that there became a second data center, and we started having lots more projects that we were deploying. And deploying also got a lot harder because I guess it wasn't really getting the attention because everyone was consumed by just trying to scale up the app and build out critical features. So to deploy, you had to learn some magical incantations. Like, what is admin? Oh, it's an admin host because we shouldn't be deploying from our local machines anymore. We had a developer change a branch halfway through a development one time, which completely broke the site and no one had any idea why. So just little things like that built up. We tried to store information in GitHub wikis and README files, but being good developers, nobody really wanted to read the manual. So in the end, deploying became a bit of an event where people that didn't know what was going on would crowd around the laptop and try and pick up some tips so that they'd be able to deploy whenever they had to. And people that didn't know about deploying probably tried to stay really far away. So if you're in an organization where you have these slightly painful processes where like you've got to wait half an hour for something to happen, but you can't exactly go away and have your lunch because you might come back and it's crashed for whatever reason, I suggest you can listen to like The Sound of Waterfalls. I think that's an online service, or just look at some beautiful pictures. Or you can fix your process. Deploying is about the user experience, not just copying files. Copying files is a solved problem. So we're going to talk a little bit about the people involved. This is the size of our engineering team over the years. The grey section is people who are outside of San Francisco. So at some point in 2014, more than 50% of our engineers were no longer in SF. And this was important for communication because you couldn't just send a message to SF and expect that all the important people knew about it. So this isn't really a talk about distributed teams, but I will just mention that something that's really helped us with having distributed teams is whenever you've got one person that's remote, everybody else kind of needs to behave as if they're remote. So that means you have to use an issue tracker like Jira, and you have to use Google Hangouts instead of putting post-it notes all over the walls, because the remote person can really easily feel isolated and not know important information. So this is a map of our offices and sort of how we were deploying. We had multiple teams, or we have multiple teams all around the world. Some of these are dedicated operations teams because they're working on an ops project. Others are fully cross-functional teams, so I'll go into what that means. Only a few of our teams are geographically distributed, but generally the people that you work with day to day are in the same office. So as time's gone on, we've sort of built out a bunch of new teams. And each one of them is responsible, among other things, for sending a monthly update to the rest of the organization what they've been doing. So that's just another little communication thing. If you look at this map, Europe is kind of small, so I couldn't really put in another indicator, but we also have an office in France. So sorry to them, I left them out. So a bit about our team structure. Each team has a product manager. In other organizations, they're sometimes called the product owner. And a bunch of engineers up to 8, including a team lead. Each team has to liaise with creative, especially if they've got any sort of front end, and QA engineers or test engineers as well. The teams aren't locked themselves, but generally people stay with their team for like at least half a year. And yeah, each team's got its own area of product and mission, like enabling developers to build searchable self-service products. Each team has its own deploy strategy, as you can see on this slide. So some are using command line, some are using Travis CI or Semaphore CI. In Melbourne, we actually have a bunch of deploys where the deploy process is hitting our own API and sending it the new code. So there are a lot of different processes going on. Each project deploys in its own way, and most, but not all of them, are backed by Capistrano, like I mentioned. Sorry. But we also have a Google Chrome extension for our internal developers, and that deploys to the Chrome Web Store using a Node module. So there's a lot of variety. There's also a different deploy process, and by that I don't mean like the specific tool that we use, but like where and when we deploy our code. So it all starts with merging a pull request on GitHub, but some projects have automated tests that will then trigger a deploy to staging or to an acceptance environment. And our high impact and high complexity projects will use the acceptance environment, and then they will actually keep code baking there for a few days. So there'll be like a weekly cut to staging and then a weekly cut to production. Some projects have a process where every single change gets manual QA testing, others don't. So there's a whole spectrum here where our most complex Git repos will have the weekly cut, but other products deploy several times per day. So basically, as we were growing, we had this documentation somewhere, whether it was in a wiki somewhere or in a README. Developers still had a lot of questions, and the process was still a little bit painful, especially if you were contributing to a core repository that was not even maintained in your time zone normally. So it got a bit hard. We built an in-house deployment tool using Rails. It's called Samson, and it handles these steps and provides a few extra benefits. So this is the homepage, the main dashboard of the app. Some of the concepts that you can see here are different projects that get deployed, and they also get deployed to different stages, like different pods or pre-production environments. What you can see in green, hopefully, is the current deployed version at that particular stage. So for each project, we have a bunch of stages, like I mentioned. They're in a particular order, so it kind of makes it easy for us to promote code, say from acceptance to staging or into production. And there are links here to stages and the output log of an individual deploy. So there are a bunch of tabs there, but the main thing here is the deploy log. And what Samson does is it'll automatically clone the repo, check out the branch, and run whatever commands you've set up in your deploy script, all within this interface. One of these tabs is files, where you can actually see a pretty good diff of the code you're about to deploy versus the previous deploy to that stage. Then we can have multiple viewers as a deploy is ongoing, and this output is actually streamed live to the browser, which is pretty cool. The deploy script is run from just a temp directory of a clone of the bare repo. So this is the recent deploys page. Really handy if you're troubleshooting issues. You can just find a project that deployed roughly at the time the issue started. You can see deploys failed, who was the deployer, and stuff like that. So there's also user management, so we can control who's allowed to deploy. But we generally try to be quite open about that, as in most engineers can deploy most products. Some of the tools that we use to build this are Rails, Angular, Bootstrap. Those four circles are Puma, the web server, which was good for concurrency. And then we support MySQL, Postgres, and I believe SQLite. So there are multiple ways to trigger a Samson deploy. There's the basic deploy button at the top there, but then we can also receive webhooks from a service like Jenkins or even GitHub statuses, and then Travis as well. And we discovered that we didn't just use Capistrano deploys, but that we deployed to all sorts of different things. We deployed to AWS, we have the Chrome Web Store, and various other targets. This is one of the integrations that Samson has. It has a few others, like notifications to chat channels. But this is Samson leaving a comment on a pull request to say that it was deployed. We find that really handy because sometimes you want to know when a particular bit of code went live, or even if it has ever gone live. We've also got an integration to send a notification of the deploy to Datadog, which may be a service that some of you use. Pretty good for profiling applications. So, how has Samson kept up, or how has our deploy process kept up with our growing needs? I guess we'll wind forward to the present day. So the numbers on this slide are bigger than the numbers on the other slide. So just to compare, this was sort of a few years ago, back to 8 projects and only a couple of languages. We've got a lot of different projects being deployed now. We've scaled up into lots of different data centers, and we've got a lot of engineers. So what have we found has worked well for us? What makes the process for deploying good? One good thing about Samson is the ability to go back in the history and see what was deployed when. So anyone in the organization can log in with the viewer role and see what changes have happened recently. It's a great tool for support, and we're only working to increase the visibility of deploys, especially risky deploys. This can really help troubleshooting issues, especially when a problem is detected outside of the time zone of the team that would normally look after it. So we've found that it's generally better to roll back a project than it is to get a half-asleep engineer to try to diagnose and fix a complicated issue, just ringing them up in the middle of the night. Although, obviously, we prefer not to deploy at 6 p.m. and sort of leave our colleagues holding the bag with whatever breaks down. But this lets us be a bit more confident that issues are going to be resolved quickly. Every engineer already knows how to deploy because all they have to do is press the deploy button in Samson. And this goes a long way towards removing the stress around deploying that we found was appearing by making the process less scary. Security is probably a concern for a lot of organizations, especially for us being a business-to-business company and having some quite large enterprise customers. You end up finding that your customers want you to be certified with things like SOC 2 compliance and various other kinds of compliance. And these can be headaches, but they also enforce certain processes. So for us, that means there's an audit log around everything and permissions. But even if you're not under those obligations, I think we need to accept that a really bad deployment can really seriously damage an online business or even destroy it. So as we grew, we've mitigated these risks by doing things like removing SSH access from the public internet and moving almost all of our deployments to Samson rather than through the command line. We have a requirement for a deploy buddy for every deploy, but this is optional for other users of Samson. Obviously, nobody likes having their access taken away, but we figured that we didn't actually lose that much flexibility, and everyone was still able to get their job done. So Samson was built originally actually with the goal of open sourcing. So that meant that we had to build it in a really generic way. And that actually paid dividends when our own process changed. From Capistrano deployment, for example, to building and pushing Docker images. This would have been pretty difficult to do if we built the app as just a wrapper around Capistrano. But it's actually a command line script runner at its heart. So another point of flexibility is we allow teams to deploy whenever they want. It's pretty important that the people that write the code are responsible for how it runs in production. It's difficult to do that if you don't deploy your code. So one alternative that was available to us with compliance approval was having a small release engineering team. So 2 to 3 people that deployed every project according to their own time schedule. But the solution we've gone with where the engineers deploy their own code has worked well because we think everyone should be trusted to deploy and everyone should be confident to deploy their own work. So, like I mentioned earlier, the code for Samson is open source. It's available on our GitHub, and the decision to do that actually helped us quite a bit. So, it forced us to write a tool that we thought might actually be useful to someone other than ourselves, which is always a good idea with open source. And that actually made it easier to use it ourselves when our requirements changed. We found ourselves just a little bit more motivated to write code to a higher standard because we were attaching our names to it publicly. Like, everybody's probably got their GitHub linked from their resume, but how many of your contributions have comments like hack, fix me, and the infamous to-do, write some tests? So we feel like we're pretty proud of the code we've written in Samson. One thing we had to do with open source was make it easy to contribute back. So it was pretty exciting when other people started using this project. And it was also a little bit surprising because, like I mentioned earlier, there are tons of tools out there and we hadn't done a huge amount of promotion. But there were often GitHub issues containing feature requests and bug reports, and we didn't really have the time to work on everything ourselves. So we made the tool pluggable and testable. So having good tests is always a good idea for any web application, especially if it's open source, because you get contributions from all over the place. So it's just that extra bit of peace of mind that the test is passing. The plugin system I'm going to talk about for a couple of minutes. It's for the features that were sort of auxiliary to the main function, which is deploying apps. So one example of something that's not a main function is like notifying a Slack channel after a deploy. Not everybody uses Slack, so it's good for that to be a plugin. And the benefit was that people didn't need to actually fork the entire Rails app and make their ad hoc changes and then never contribute back to us. So hopefully this has meant that there's going to be a really good community around this app. These are the plugins that we've currently got on our GitHub. So building and pushing Docker images, configuring the environment for each deploy, and that gives us reusable variables, which is kind of handy. You end up not repeating yourself even in a deploy script. Kicking up Jenkins jobs, notifications to chat, pipelining deploys. So that's helpful if you obviously want to deploy a whole bunch of things one after the other. Integration with the Kubernetes cluster. That one I'm personally really excited about. Unfortunately, we can't use it yet because our internal Kubernetes cluster isn't ready, but that plugin's doing really well. So how do you generate a plugin? Let's say that I want a plugin that automatically orders some pizza for my QA team if I do a staging release after 5 p.m. For whatever reason. So we've got a Rails generator that creates the skeleton for a basic plugin. And a plugin is a lot like a Rails engine, but you can see that it has a gem spec. That's because they're treated a lot like gems, which is also the reason why we need to bundle install again after creating a new plugin. So Samson plugins can also be gems in an external repository, and that's totally fine as well. Plugins hook into a whole lot of events that are provided by the main application. For example, you can respond to an event that's fired after each deploy. And that's the one that I'm going to use for this example plugin. So there are also view hooks to add UI items. So, is this real? Let me just mirror. It's live coding time.
Live coding. Stage deployment.
I would love to do a live deployment, but I'm actually not on the internet. So you're going to have to cop out of that. So I generated a plugin. And it was, after running the generator, it was as simple as adding this code snippet. So detected the times after 5 p.m. If the deploy was to staging, and the project was my shonky project that I like to deploy late at night that makes QA set. And then from there, I can just call out to an API that orders pizza, right? It's that simple. But then I decided, what if the QA team were not in the office? What I really want is to save myself a bit of money, so I'm actually going to make a button that they have to press to order the pizza. So that means I had to change the views a little bit. So I hooked into a view to render my own template, which is going to be the link to, say, ordering pizza. This isn't very good code style, but that meant that this little link got rendered inside of the deploy page after a successful deploy staging. So this being a Rails engine, it's got its own routes. So I made a route to get pizza. This is strictly not RESTful because it mutates state, but I just thought it was cool to call it that. And a controller. So if I just go to my web page and I create a deploy, hang on a minute. So I'm just booting up the Docker image. And because I'm not online, the deploy is going to fail because it's trying to fetch from GitHub. But that's okay, because I've disabled the check for making sure the deploy was successful. So you can see that this is my plugin being rendered here. I can click this link and I get a 200 OK because the plugin doesn't actually do anything. But it also sets some state on the deploy, so when we go back, the button's gone. So that's because I've also got a migration in my plugin. So they're quite powerful, there's a lot that they can do. Okay, back to not mirror. Yeah, so that was a quick rundown of a plugin. I would encourage anyone that's sort of interested in how Rails engines work in general to check it out. This is a shout out to a company nearby to our Melbourne office called Invato, who actually created a version of Samson that allowed them to deploy their app with the press of one button. So that's kind of cool. So what gives us serenity in deploys? We want them to be stress-free and reliable and performant and all that good stuff. So I wanted to try and do a little measurement of has Zendesk achieved this goal. And I was reminded of this Andreessen Horowitz presentation called Mobile is Eating the World. So the gist of these slides is that when a particular technology is new and undergoing heavy iteration, it gets heaps and heaps of mentions in literature, but once it becomes an accepted fact of life, like steel, railways, and computers, the mentions really tail off. So I used a Google App script to search my email for emails related to deploys, obviously ones that were not generated by a machine, because we expect to have more and more of them as we have more and more deploys. And we have over 100,000 deploys in our Samson instance. So this was the result. It looks like Zendesk still has quite a way to go. Since the start of my Zendesk career, we've been discussing deploys more and more and more as we've been undergoing growing pains. Some of the alternatives to our tool are Spinnaker, which is made by Netflix. It's a replacement for their previous project called Asgard. CodeShip, Ansible, Atlassian's Bamboo product, and AWS Code Pipeline. Some of these are cloud solutions. The reason that we created our own was because these weren't all as available or mature as they are now. And maybe we have some niche requirements. So there are heaps of changes we want to make into the future, but I'm out of time and they're not extremely interesting, so I'll skip to the key takeaways. Pick the right tool for the job. Open source your tools if you can. It's going to probably pay dividends back to your organization. And at certain points, you need to work on tooling rather than directly in your product. So you've got to identify the pain points in your particular organization, especially if they're sort of creating dangerous and risky processes. So we've got a Bootstrap script and a decent instructions in README for how to get started with this project. We've got a Docker image. Quick shout out that we're hiring lots of people in Manila. These are some of the people you might get to work with. This is our APAC support team. Thank you.
We have time for, we have a couple of minutes for questions. No? Okay. Thank you again. This will take a 30